Hey friends, did you know that by the time it reaches Earth, satellites' RF transmissions are typically 1 billion times less powerful than mobile networks, but can still deliver data at broadband speeds? Hrishi Shelar is here to show me how Azure Orbital provides a fully managed ground station as a service to receive, process, and store data from satellites today on Azure Friday. Hey friends, it's Azure Friday. This is awesome. This is awesome. Azure Orbital. We're here with rocket scientist Hrishi Shelar. How are you?
Hey Scott, I'm doing great. How are you?
I'm pretty freaking good. And like, no disrespect to your product or your science, but when I read this, I honestly thought that Rob was messing with me. Rob is our producer here on Azure Friday because I thought it was like an April Fool's thing. Like that, we have a satellite ground station as a service. That has got to be the awesomest cloud service that I have ever heard about.
Yeah, it's pretty amazing. And it's that time now where space is going to start coming to the cloud and we're going to see even more innovation and new services and just value add products for everyone, for us, you, everyone.
How would people get satellite data before? Like, if whether it be a little satellite or a big satellite, like how was it done before, and what are we basically removing from? Because when you do something as a service, you're removing the
Right.
boring parts, right? So I assume the
Oh,
scientist, the rocket scientist, wants to get the signal and wants to like deal with it, but they don't want to deal with like the databases and the tables and learn SQL and stuff, right? You want to remove the boring parts.
yeah, that's perfect. Like perfect description of what we're trying to do. How it used to be done
Mm-hmm.
is you would have to build these very complex, expensive ground stations, which are basically those giant satellite dishes that sometimes you see on top of buildings or by the road. You've seen them on NASA's social accounts. Anyways, people would have to build those themselves,
Oh
and
wow.
that's a pretty complex process. It takes a lot of money and you have to put them across the world. So it's different in each country. Dealing with each country has its own problems.
Mm-hmm.
And this is a common need for a bunch of satellite operators. So we thought we could just offlift that complex process, that arduous uh, task of dealing with all that build out and dealing with regulatory, and we take care of that. So you just have to come on and pay per minute. It's basically a pay as you go model. So you don't need any upfront dollars or anything. You can just log into Azure, choose Azure Orbital. If you're a satellite constellation operator, choose the passes you want, and then you just pay per minute. And it's all seamless experience.
This is the most extraordinary example of hiding complexity with layers of abstraction that I
Right.
can even conceive of. Because I used to, I used to work on a website called 800.com before Amazon, like 800.com, and we'd sell DVDs. And the boss would say, "Can you scale out the system?" And then he'd go home. And then he'd come back on Monday and the system was scaled out. He's like, "Oh, it's amazing. We've really," well, all weekend long, we were racking servers, right? So in his mind, he moves the slider bar and like the thing scales, but it's us racking servers. So now with
Yes.
Azure, we've hidden everything behind a slider bar. We've got checkboxes for stuff. And there are still physical machines, and there are still people who rack machines, and there are still people who set up these giant warehouses and data centers. But the business person doesn't care because that's not their business. So you're really freeing the satellite consolidators to do their business and not think about the buying the land to put the dishes on and all of the details.
Yeah, that's spot on. If you're a satellite operator, or let's say you're a satellite space startup, which is kind of crazy to think of that you'd never have, you've had startups for a decade now in the app industry or online startups,
Yeah.
but rocket launch costs have just gone down drastically. I'm sure people are aware of SpaceX and other companies, but their innovation means that there can be things like satellite space constellation startups.
Mhm.
Now, we make it very easy for these guys to focus on the business because they have that slider approach.
Mhm.
If they start off with one spacecraft, they actually get access to an entire network of ground stations through Orbital, which is something they classically couldn't do. And then as they scale up, they just request more time,
Mhm.
more passes, more minutes, and then it's all available on Orbital. So they are perfectly matched in their business needs and expenditure, not having to like you mentioned, worry about building out those racks themselves or building out those ground stations. We make
That's
it we make it so that they can focus on their business and the product that they probably want to deliver. And this stuff is just abstracted for them.
that is a wonderful example of what the cloud really is you focus on your business and we'll worry about the technical stuff. Fantastic. So can you show me a demo? Do we have a satellite there in your living room? What are we doing?
Yeah. So what we have here is a pre-recorded pass
Okay.
of of uh, of a public satellite known as Aqua, NASA Aqua,
Okay.
which is a weather satellite that NASA operates. The cool thing about this spacecraft is that it's continuously transmitting for anyone to receive and get the data from to look at. Uh, it is in a frequency band that you and I don't necessarily always have access to in 8 gigahertz. But what this satellite allows us to do is show the world how the system works.
Mhm.
You would be able to also log into the portal, and if you wanted to get familiar, you could do a similar exercise right here, and you could schedule a pass with Aqua and watch the signals come down, and you can get familiar with it.
Mhm.
So we have a pre-recorded pass here, and the reason it's pre-recorded is because it's quite the feat to do a recording and a satellite pass in one time. So we've just made it simple for today,
Sure.
and I can walk you through what the system looks like here.
Sure, I'd love to see that. Before we start, though, how fast are these things going? And if we were theoretically to try to do something like this live, is it like, okay, we've got 6 minutes as it goes in the arc length of where my visible sky is, or like how does that work?
Yeah, it's a great question. So these things are going around Earth. Well, NASA Aqua is going around Earth every 90 minutes,
Hmm.
but you have to remember the Earth is also rotating. So what that means is for this type of orbit, the passes are either at 2 a.m. or uh, late in the afternoon, and either very short in time. So we'd have to be right on the nose to time these two perfectly.
Mhm.
And even between days when they occur, they can go back and forth.
And does Azure Orbital make that easier for me that I don't necessarily have to be there to do the analysis, right? I don't have to do it live, right?
Oh, absolutely. So Azure Orbital is just not just ground stations, but there are mission planning tools that are available. So we will do the orbital propagations for you. And when you come onto the portal, as you'll see here in a few minutes, you just say, "This is my spacecraft. This is its orbit. Tell me what's going to be there in the next 10 days." And you can just click, 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 choose them, and it will just run when those passes occur. The system will know the satellite's coming ahead, tell those antennas to go do and point up, and then you will start getting your data. So
Wow.
we try to make it as easy as possible for the operators too, understanding that, yeah, these things can be a complex scheduling problem.
I love it. This would have made the movie Contact go so much differently than it actually did. All right, so
Yeah.
let's see some satellites.
Okay, so I've pulled up my screen. Can you guys see it?
Yep, looks great.
Awesome. So when you get into the portal and you navigate to Azure Orbital, you'll see these three kind of big steps here. And we try to make it as simple as possible. So these are the 3 steps that you need to do to get your passes. It starts off with registering your spacecraft, where you enter details such as the frequencies that are being used, the orbit, and an ID. Then you move on to the contact profile, which describes what you're looking for in the antenna requirements, and
Hmm.
some other parameters that just help us define how we coordinate that and conduct that pass. And then once you have those two, step three is where you tie them both together and then start making your reservations.
It is amazing
And
to me
that's
that you're
yeah,
making talking to a spacecraft as easy as like registering a Raspberry Pi for like an IoT portal.
yeah, and that's a great observation because thinking of spacecrafts and this whole kind of mechanics of communicating with these devices far away is very much like the IoT world. There's a lot of similarities.
You know, the other thing that makes me wonder, and this is probably for another whole show we should talk about, is the idea that satellites, I assume right now, are primarily sensor devices that then spit back raw data, and then the work happens over here. They're not exactly clever. Their job is to stay up there, think about power, think about sensing, and then bring the data back. But it's the new edge. The edge network could theoretically be up there, and you're managing an edge network device, regardless of whether it's RF or Ethernet or whatever, right? And
Right.
there could be additional processing up there. This could change the design of satellites themselves. They could become smarter. They could become different if they know the context, the larger cloud context in which they exist.
Scott, you should come and join Orbital, I think. I think you're very acute in these observations. Absolutely. As satellites become cheaper, just like launch vehicles, as they
Mm-hmm.
get more powerful, because the compute industry is so innovative right now, there's endless possibilities, and those workloads can happen on the cloud, on the satellite. We are the bridge between both those worlds, and we offer like Azure. You can chain services, and there's so many different ways to think about how you build out a solution. It's very exciting,
Oh, this is so
and this is
cool.
just a new service. There's what you described. It's all it's in the roadmap. We will definitely get to a scenario like that.
You know, I have to say this. I used to think the coolest thing that I'd ever seen before was my Raspberry Pi Kubernetes cluster. But now I
Yeah.
need like a mini satellite. Like, what's the size of a satellite? How do I get one of these in my house? I need to. They're actually smaller than you'd think. Like, I've seen satellites. You know, they're kind of like about like that, right? Yeah.
Yeah, I've worked on satellites this big
Yeah.
to as big as a mini fridge,
Yeah.
and they can get as big as a school bus truck,
Oh man,
uh, if not larger sometimes.
that's awesome. Okay,
So there's a
sorry,
huge
sorry to
range.
go off on a tangent. All right, let's go back to onboarding a spacecraft.
Okay, so I'm gonna click play here,
Okay.
and then we'll see us tab through a couple of these options. So describe the spacecraft, enter those details, put in the contact profile details, and then you're ready to schedule.
Mm-hmm.
So we've already created a contact profile here. I'm going to pause for Aqua, which is that spacecraft we just described.
Okay.
And here we have some simple requirements that describe what's your minimum time that you need for a pass. So we have here 1 minute. That format is just the Azure time format. Some other requirements like elevation is provided, and auto track and X band. But these are all, very fine details that have to do with this art of satellite communications.
Mm-hmm.
So on, and we've already populated a contact profile here for Aqua. So likewise, we've done the same for the spacecraft. So you'll have a spacecraft object, and we have the NORAD ID, which is a way to track objects in space. And then these two items here, TLE, you'll see there's a TLE line. And these are just ways the industry used to describe the orbit. It's pretty cool, the whole science behind it. But with these two lines, you get a full description of the spacecraft orbit. And also, you can use this to propagate where that spacecraft might be a day from now, a couple of days, a week from now. And so we use this. This is specifically what enables us to know where the spacecraft is and then marry that with where the ground station is in time so we can reserve your pass.
I see. So if I may try to understand this, when I, as a layperson, see a TV show where there's like a number, comma, a number, I go, oh, hey, it's latitude and longitude. That's a pair that describes a place on the planet. So a TLE, that two-line element, describes everything that one needs to know to describe where the satellite is, how it moves, its orientation, its attitude, its behavior. It's multi-dimensional, encoded into like one thing where you can copy this GUID, this two-line element, and say, yep, that's everything you need to know about the satellite. Is that correct?
Yeah, that's absolutely correct. It's exactly like a latitude, longitude, with some extra spice for direction, velocity,
Yeah.
and inclination, all sorts of fun things. But that's a full description of a spacecraft orbit, just like
Awesome.
how coordinates fully describe where you are on Earth.
Sweet. It's so interesting to see that it's 2021 and that we're looking at a 60-year-old data format, but it was really well designed and thoughtful, and it's the one everyone agrees upon. So that's how we talk about satellites. It works.
Right. And this is a very common representation. It's industry standard, even globally accepted as a way to do this and describe orbits. So you come in here, you can create your spacecraft object, you enter these items, and this last field, authorization status, is a final check that we do to make sure that the spacecraft that you want to talk to is actually a registered spacecraft or is authorized by the FCC for these type of transmissions. We do have to make this check just to be sure that we're not going to do anything inadvertent.
Cool.
All right, moving on. And tabbing over to the contacts page, you see that there's nothing there. So let's go ahead and schedule one. So we come in here, you choose the contact profile. The ground station is describing which region of, the location that you want to do the scheduling on. So we have multiple regions. So West US 2 is the Pacific Northwest. You put in some start times and end times. And this is the time window in which you want to do your reservations.
Does this imply that there is a satellite dish on top of an Azure data center? Because the ground station is the processing station to do the ingress of the data, but there is some, where does the actual antenna, where's the actual capturing of the thing? Where's the dish?
Yeah, that's a great question. So we have installed these antenna dishes at our data centers. The exact locations of the data centers are, once you're onboarded in the system and we know who you are, we can absolutely share those. And there's also, maybe after this demo we talk about it, we have partner networks too.
Awesome.
Which is what makes this extremely powerful, is that this interface enables you to get access to Microsoft-owned dishes, but also a very wide, vast, globally available partner network. So you can choose these regions in this drop down here.
Awesome.
And I've entered some time windows, and the system comes back with these list available passes. So it took the TLE, it took my contact profile, it took my regional preference, and my time window, and said, hey, looks like in this upcoming days, you have these passes available for that region. And it'll tell you how long that pass is, which is just part of the orbital geometry. Maximum elevation is used as a figure of merit for the satellite pass. All it does is describe how high in the sky the satellite is passing over. So we're going to go ahead and choose one on the second line here, which is the 8-minute, 50-second pass at 15 degrees.
This is
15
awesome.
degrees is pretty low.
It's like
Yeah.
picking an Uber for a satellite when it's like, yeah, that second one might get a little longer, but that's the better choice for me. Like you gave it your destination, you gave it your TLE, it gave you an option of all the different drivers that are available, and then you make an educated decision.
Yeah, that's great analogy. Exactly.
Awesome.
You can gauge which one, like if you need a faster driver that needs to come sooner, you could do that. Or if you need a driver that will, that maybe this passes longer time, you could do that. So we choose this one over here and we schedule it. It's going to create this contact pass for you. Once it's done, you can click on it, and then we go back to the spacecraft's page. And on the contacts tab, we'll see that our thing is scheduled. And then here you can get additional details for when the actual start time is, when the actual end time is.
So in the movies, when you are looking for something, they move the giant satellite and it's like looking over there. Can I and another person look at two different satellites at the same time, or is it like synchronous and we all have to get in line for our time on the satellite dish rather?
Yeah, great question. So the dishes are directional. So it's a giant parabolic dish, and its focus is very in a particular point in the sky as it moves.
Mm-hmm.
So what we have is we have multiple dishes at the sites to solve this. They provide redundancy to each other, but also the ability to handle, let's say, if multiple reservations were being requested for a site. So that's how we solve that. And then on top of the ones that we install, the partner networks further provide this scheduling optimization.
That's cool. So there's a lot of different options, and I'm not going to be fighting for time unless this becomes wildly popular and everyone is like checking out satellites on Azure Orbital all day long every day.
Oh, we do hope it. The goal is to get so much demand that we're just putting these dishes everywhere.
That would be an awesome problem to have. Okay, so you got your reservation start and end time.
Okay, so we're going to keep playing, and we'll cut forward to the actual pass here. And let me pause the screen and describe what's going on. So this is at one of our partner sites, USCI in Brewster. And they have a 7.6 meter dish set up here. And USCI stands for US Electrodynamics Incorporated.
Mm-hmm.
For those curious, we have a live webcam view here. And these 4 tabs are kind of a behind the scenes peek for that I'd like to show you, just to also talk a little bit about the cool technology that we're adding on top of this. So this is a whole nother layer that we didn't even touch, but now we will get to see what it is. So what's going to happen is we're just coasting, waiting for the satellite to come overhead. It looks like a pretty good day in Eastern Washington.
I'm noticing, though, forgive my ignorance, but you said at the beginning of the conversation that this was going to be around 8 gigahertz, and the numbers that I'm seeing on the screen, like 600 megahertz and 1 gigahertz, aren't the same area.
Right. Yeah, that's a great observation. So the antenna is not only just a RF focusing device. There are some components in the antenna kind of located right at the feed or behind the parabolic dish.
Mm-hmm.
And what they do is they take your high frequency, and we mean really super high, like extremely high. 8 gigahertz is extremely high. And it, using some RF magic, it just moves it down a couple of notches.
Oh, okay. So it's like when we look at X-rays or we look at heat stuff, or the predator sees infrared, we're seeing it in red and green and blue because we've taken something that isn't visible and shifted it down into a spectrum by which it is visible. In this case, we've modified how one perceives it. So you're making it more accessibly perceived.
Right. Right. That's exactly what's happening here. And this, what we're seeing here, maybe let's just go into the technology here real quick. What this screen is showing is a view of the front end. And another thing that Azure Orbital does differently is we've virtualized the RF. I know, so that's kind of a like a big buzzword, but what that really is like, let's say in the classical way of doing things, you would have a hardware modem. So you'd buy this big box, and you'd put it near the ground station, and it would take in the RF, and out come bits.
Hmm.
Well, the problem with that box is it only does one type of RF signal scheme. So if you wanted to talk to multiple spacecrafts,
Mm.
like you'd have to have a kind of maybe a unique box for each spacecraft, and that doesn't scale, right? Because we want to be able to add more customers, more different types of spacecrafts on like very fast, fast-paced, ad hoc way. So what we do here is we virtualize that modem, and it's a extremely cool kind of cutting edge technology in the satellite communication industry right now. We take the signal, we slice it up really fast, and we record that signal. So it's called digitization. So we digitize that signal, and that is piped to the cloud. And in the cloud, we've partnered with these leading software modem companies, Kratos and Emergent, and we instantiate that hardware box, but virtually, and we feed in the samples, and it does the RF to bits. But now, because this is a software modem, we're very flexible in the type of RF signals we can accommodate. So we've
That
kind of decoupled this unique problem and are solving it in cool ways.
that sounds as revolutionary to the RF and the satellite communications industry as software-based networking was to
Yes.
Azure, to Azure and the network itself. Like I was using that example where I was racking servers. Like I was literally plugging Ethernet in, and I
Right.
don't do that anymore. It's just not a thing because it's been abstracted away completely. And the flexibility that it offers you, the idea that you have all these signals coming in across a spectrum and you just turn it into bits is overly simplistic. So you've sliced it farther back, you digitize the entire thing, and then wait until the last minute to turn it into bits because you don't want to lose any fidelity at all.
Exactly. And that's what makes this so powerful, is because you get access to a worldwide network of dishes. So you can pipe in from anywhere, and then you can process from anywhere too, in exactly how you want to process. And this is something you couldn't do if you were rolling out your own ground station with your own hardware-based modems. You just didn't have that
That's
flexibility.
amazing. All right.
All right, so let's walk through this. So we're waiting for the satellite to come up. Um, we'll go through these other tabs, and these two systems here, this Data Defender product, is what pipes those RF streams from the ground station to the cloud. So there's one at the actual site, and there's one in the cloud. So that's where there's two Data Defender tabs. And then in the cloud, what we see here is an example of what that software modem looks like. So this one's Quantum RX by Kratos, and it has all the parameters that you would expect for a hardware modem, except we've just instantiated this in basically real time as needed in the exact scheme we want. So once the satellite comes over, we'll see some data flowing. So I'm going to play. And then we've got this bucket here, which is going to output. That's where the data will be output. So the satellites come over the horizon. We're seeing that the digitizer is seeing that signal come up. The data defenders are now streaming that digitized signal into the cloud. So it's doing that slicing really fast, and we're getting that high fidelity analog to digital signal going straight to the cloud.
And that is 300 plus megabits. That is a lot of information. It's a flood of information.
Right. So 300 megabits is the RF signal, and that can scale. Right now, it's 300 megabits. It can scale up to many Gbps depending on the application.
I always wondered how my DirecTV was able to have so many channels.
Oh yeah. So in this modem here, we see that we're looking at the signal, this right from the spacecraft, and it's all software based. And the spectrum plot looks good. We're looking at the carrier lock state. It's all locked. This is the signal to noise ratio, which is looking really good.
And there's no
And
one else in that space interfering. There's no one like with an AM or FM radio. You can kind of hear two channels at once, or someone can leak into your signal space.
yeah, great question. No, because the dish is directional. And if it were to happen, we would, Azure would take a look into what the interference is. There's a bunch of work that we do for pre-coordination of where these dishes go to ensure that it's a quiet environment for the frequencies that we expect people to operate in.
Amazing.
So that's just part of the service, right? It's not. This
So
was
that's
a
an
headache
example
that
of a problem that I would have had
yeah,
to worry about, and now that's just
exactly
not my business. That's so
right.
awesome.
So we work with regulatory folks. We work with we make sure the data centers themselves are pretty frequency clean. Interference is the last problem that we want. So great question. Yeah, so just tabbing through the different items in the software modem, these all just represent parameters typically associated with satellite communications. And everything here is looking really good. Everything's in lock. So we're getting the data from the spacecraft. And this is typically what we would expect a majority of the satellite passes to look like. You go through the three-step process, you schedule a pass. At time of pass, you're waiting for the satellite to come over the horizon. Oh, we jump forward to the end. Yeah, we wait for the satellite to come over the horizon, and then the data starts coming in. It's getting digitized. It's getting reliably sent to the cloud. It's getting processed, and this is a good state for 8 minutes. Nothing's going wrong. No drastic changes. This is a perfect satellite pass. So in this demo here, we've cut to the end. Since the pass was 8 minutes long, we kind of just showed the first minute, and we cut to the end. And we're taking the output of this modem, and then there's a script in the background that's processing this Aqua data, which you could download from NASA's Aqua website. Since it's a public spacecraft, they kind of let you use these tools for free. And we'll see here that our script is able to pull out these files here, which are the image files, but also some scientific data files. We're going to open one. Let's see if I can just skip ahead to when it gets downloaded. Right. So we've downloaded one, and then we're using, I guess, some some pretty funky tools to look at this data because it's unformatted, unpolished data. It's just raw off the sensor, so it's not just like a JPEG that comes down. You can imagine it's a very, very high volume, very raw formatted. Just like when you capture on a DSLR, maybe it's raw pixels, but imagine that tenfold the complexity. So we're using this tool to take a look at the image here, and we'll see it pop up on the screen real quick.
Does every satellite agree? Like the two-line element that you showed me is effectively a packed data structure in the classic kind of like C data structure, where it's like these 2 bytes mean this and these 8 bytes mean that, and then you just basically have binary data and you chop it up because someone decided arbitrarily that these 8 bytes mean that. Does every satellite get to decide how their bits are, or do they just use a standard format?
That is, wow. Always impressed with your questions. No, it really depends on. Let me show you this image first because it's on screen. Right. So here's the image on screen. We're looking at some clouds over the ocean, it looks like, and this was just pulled in real time, as you saw on this demo from Aqua. So
Mhm.
all within the span of 10 minutes during which we did this recording. So getting back to your question, is there a standard format? Honestly, one wishes for a standard format, but that's not the case. Uh, the satellites are very different depending on who builds them, which country is building them, which company is building them,
Mhm.
from who the satellite builder was. Because you can or build and procure spacecrafts now.
Mhm.
So, but the cool thing is, because we've virtualized everything, offer it in the cloud, it's so flexible that you're not limited now by those hardware platforms that you might have been limited in the past. You can build a service however you want. You have the selection of dishes up front. You have the selection of software modems, ability to run them in any region, ability to chain that with any Azure service.
Mhm.
So you have your own product and you have your own satellite. You can own the chain end to end.
So this is going to sound totally obvious because I'm sure that the audience who's sticking with us has figured this out already, but you just blew my mind because when you said chain with other Azure services, that's where I just
Yeah.
went like, oh, duh. I can bring it into any Azure service, queues, storage, processing batch, flows. Once it's in, it's my data and I can go bananas.
Yeah. So I've also just pulled up on the screen here
Mm,
this
I
is
see Data
online.
Factory and yeah.
Yeah, if you go to docs.microsoft.com, put in Azure Orbital,
Mm-hmm.
you would be able to see um, this page here and this graphic I just pulled up that describes exactly what we were talking about. The items in dark blue is what we handle, the hard stuff, the things that are abstracted, made easier, made seamless for you, and the items in light blue are what you can focus on. So you can focus really on security for your products or your spacecraft. And then this data processing pipeline, honestly, this small blue box doesn't do it justice. That is as expansive as
Yeah.
all of Azure's services, which is AI,
Mm-hmm.
ML, databases, IoT, anything like literally the a myriad of options
You're right. The
exists in this
cloud is your
pipeline.
oyster. Yeah, we've done
Right.
dozens of videos on the power of Data Factory and the processing pipeline. The amount of data that can come in is immense. The amount of chewing on that data is immense.
Right.
The marriage of satellite ground services as a service and Azure itself is genius. Like I'm gushing. I know I work
Yeah.
here, but like all of the layers of abstraction from the early satellites in the 50s, 60s, and now, and the cloud, and layers of abstraction and software engineering and data structures and science and RF, and it's all coming together into just lovely solution. People in this industry must be absolutely freaking thrilled about this.
Yeah. There's a ton of interest, and I don't think we've even gone past the tip of the iceberg.
Mm.
Honestly, we're just at the beginning of all this. uh, People in the past built their own ground stations, built their own data processing pipelines on prem. In the past few years they're moving the data processing into the cloud. Now ground stations going into the cloud. Now what comes next is, we just want to support all these crazy scenarios, these next gen spacecraft systems. And what this means is that end to end solutions just become easier, faster, more valuable, and we can extract more value out of the spacecraft. So everyone gains to benefit.
Awesome. So this is in preview. Folks that are interested can go up to the Azure Orbital overviews. They can get in contact with your team, express their needs, get involved. What can enthusiasts do? Because not everyone who's watching this show has a satellite that they want to listen to. I would suggest that they look at software-defined networking and just try to listen to the local radio station and get some RF signals themselves, just to be an enthusiast. But what can I do? Because I don't have a satellite.
Yeah. So software-defined networking is a great analogy for this. There are these hobby-grade software-defined radios that you can get now, which is so
I have a
cool
little one that it was like $19.
Yeah, right, and it just makes it accessible for everyone. And I think you could get that like that $20 system. You plug it in your computer and you can listen to FM radio, and that's basically what we're doing on a massive scale. So definitely, if you're interested, check those out. There's this thing called USRPs. That's just a step above the $20 dongle. There's a open source platform called New Radio, which is incredibly powerful. I've used that on personal projects in the past many times. And right now we're in private preview, so we're working with some customers to show them how this system works. We'll go into public preview later this year, which means it would be open for potentially more hobbyists to come on and get their feet wet with this advanced technology.
This is very exciting. This has been the longest and most awesome episode of Azure Friday we've ever had. I really appreciate you. I really appreciate you hanging out with me.
That's very high praise.
No, I'm telling you, it's like 3 times longer than ever, and we've never had so much space and so much awesomeness and satellites and everything. This has been super amazing, and actually it's my birthday, so it's really my best birthday gift ever.
Oh, happy birthday! I'm glad this is we're able to have such a awesome talk.
All right.
On your
I am just gushing about the excitement about what's happening right now in space and in the cloud. We are learning all about Azure Orbital today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.